All right, let's go over quiz number 16. In quiz number 16, we're going to apply implicit differentiation. Of course, essentially, we are applying chain rule. And there are two questions on this quiz. The first one is, the implicit equation, and the second one is also an implicit equation. So we're going to find the dy dx. Okay, so let's write down the fundamental question. Find dy dx by implicit differentiation. Okay. So we got y multiply cosine x equals to x squared plus y squared. That's the first question. Of course, we assume that y is a function of x. So when we take a derivative, we take a derivative on both sides. So if this equation is an if statement, right? If that's true, and we take a derivative on both sides, okay? On the right-hand side, it's necessary to have a parentheses. Okay, on the left-hand side, it would not be necessary. And then we differentiating, the left-hand side is going to be applying product rule. We know product rule, right? So think out aloud. Product rule, we have derivative of f times g equals to f prime g plus f g prime, right? So you have f times g, you just in one, you differentiate f, leave the other one alone. And in the second one, you differentiate the other and leave the first one alone. All right, so the derivative of y, so this is your f and this is your g. So the derivative, so that's you're gonna get dy dx. Okay, and cosine x. This will be, you can write it this way, that will be fine. But you also have another term. You also have another term, and this time you're gonna take a derivative of cosine x. So y is left alone. The derivative of cosine x is, of course, is negative sine x. On the right-hand side is the derivative of sum. So you take a derivative of x squared, which is 2x, and then you take a derivative of y squared. And with respect to dx, right? And of course, we know we're going to apply chain rule. So we're going to have dy dx we divide by dy multiply dy. That's essentially what it is. You can also just write this down, right? Directly. Okay, so this will be 2y. 2y. So you can write this down directly and leaving this piece optional. Okay. So now by this time, you may like to put a cosine x in the front of it. Okay. That's usually preferred. That's usually preferred. But if you write it down correctly, clearly, that's not, usually it's not an issue. And next, we're going to bring terms with dy dx together. Okay. So we're going to leave, we have cosine x times dy dx, subtracting 2y multiply dy dx. On the other side, okay, we have 2x left, and we're going to add, because here we have subtract, we have a negative y times sine x. So we're going to add a y times sine x. Okay, so for you to see better, Okay, so let me rewrite this line. Okay, so this piece becomes subtracting y times sine x. So that's how we add y times sine x. Okay, some of you, when you write your work in between the lines, you write adding this, adding that. Don't show that piece of work. Don't show it if you can. Okay, put those work on your scratch paper. The reader doesn't need to see that. Your reader does not need to see that. What do I mean by that? Okay, what I meant, okay, you thought you're showing work. You thought you're showing work. You're gonna say, hey, I'm gonna subtract these two pieces, right? You're subtracting that piece on both sides, right? And you're adding that piece. You're adding this piece on both sides. I see this very often. I see this very often. It makes a mess. It makes a mess. So if you have to do this, do it on scratch paper. Okay? All of these, cut it out. Please cut it out. You are in calculus. Please cut it out. Okay? If you want to do this, you see better for yourself, do it on the scratch paper. Okay? Your reader does not need to see that. Okay? So cut it out. And next, you have a cosine x minus 2y dy dx. Okay, so you have the right-hand side stay the same. And divide both sides by whatever is in the parentheses. So in the end, the dy dx is equal to this piece, which is going to serve as a numerator, and whatever in the denominator, divide on both sides. Okay. I see a variety of things, people showing that you're actually dividing this. You're actually dividing this. Oops, sorry. You're actually dividing this piece in a rather messy way. Okay. If you show it this way, that's fine. But you really don't need to show this step. No need to show. No need to show. But I saw this. Okay. I saw this. Okay, this piece, no need to show. Cut it out. When you get to this point, some people from here, they show this way. They show it this way. They show it this way. Please don't. Please cut this out. There's no such showing of work. Okay? You don't see this way of showing work in any literature. So please don't do it. So please cut this out. If I see this again, I'm going to take points off. Okay? All right, so don't invent those new things. Okay? So cut this out. Please cut this out. Thank you. Okay, so note, please cut this out. So for your work, okay, Just nice and clean, just nice and clean. And you can even have a shorter version of it, right? So a better version of it, okay? You can cut this piece out, right? Yeah, that'll be fine. That'll be fine. Okay. You can, of course, even cut this out, right? You can even cut that out. But anyway, I think I have pointed out most of most of the things that what you need to do, what you don't need to do. All right. So let's look at number 2. Let's look at number 2. E to the power y multiply sine x equals to x plus xy. So we get to use the product rule again. So I'm gonna keep this under. So we only show question number 2. Okay. I'm going to apply product rule on this, on the left-hand side, on the right-hand side, on x times y. So then first we're going to take a derivative on both sides. Okay. So derivative dx on the right-hand side, we have to take a derivative with respect to x. Okay. Equals to, right? The left-hand side. We will take product rule. So the derivative, okay, if you want to set it up this way, you can write derivative with respect to e to the power y, and then times sine x. And here, if you write sine x behind, that's going to cause a hell of a confusion. So what would be helpful is that if you put sine x in the front. Put sine x to the front. So you essentially, you are doing, if this is your f, you're doing f prime. So f prime, this is f prime, and this is g. You just switch the position. Okay, so this is your g multiply f prime. You don't need to show this on your work. Okay, I'm just showing this to show you. Okay, so you're doing that piece. Plus fg prime. So this is f, right? So the e to the power y. And then you take a derivative of sine x. So g prime, g is sine x. The derivative of sine x is cosine x. So you can put it there. Okay. On the right-hand side, you take a derivative of x, that the sum of the derivative of x is 1. And the derivative of this product, you're going to apply the chain rule again, the product rule again. So this is your f, and this is your g, supposedly. So your f prime is 1 times y plus fg prime. So fg prime, g prime is a dy dx. Okay. So your first step could be something like that. You don't need to show this piece. Okay, so now I'm removing it. The question is, how do we, so we're done with that part. The only thing we left here is right here, dy, right? So this piece, you're gonna use chain rule, right? We're gonna use chain rule. So this is gonna be dy, and then dy dx. Okay, put it right here. Divide by dy, multiply dy, right? The derivative of e to the power y with respect to y is e to the power y. And then multiply dy dx. You can put this piece right here, replacing it. So this entire row, okay, that piece is replaced by this guy. Boom. Okay. To be clearer, of course, here 1 times y is y. To be clearer, because you have a sine x times e to the power y, this could cause some confusion. So now you can put this one over here, e to the power y in the front. So this will be very, very clear. And of course, you can remove the dot here. Okay. And now we have dy dx. We have two dy dx terms. So we're going to move them together. And any term that does not have dy dx, we're going to move them to the other side. So now the left-hand side, we have dy dx term. Subtracting this piece. And that equals to 1 plus y, stay where it is. Subtracting, so bring this term to the other side. Okay, if you have to do subtraction, the same thing, do whatever you have to do on your scratch paper. Okay, on your work, it should be nice and clean. It should be nice and clean. And next, factor out the dy dx. Okay, and the e to the power y multiply sine x subtracting x. And the right-hand side stays the same. And next, it is dividing. Dy dx equals to, okay, numerator, denominator. Okay, that's done. Finished. Okay. All right, so that's quiz number 16. If you have any questions, please don't hesitate to let me know. Thank you for watching.